We can see okay?
Yeah.
Now, let's get started on this fine Monday morning. It's actually pretty nice outside. Right, the first question. I'll need someone to read it to me. Does anyone have it handy? Do you mind reading it to me?
Yeah, I read it.
You can read it, thanks. What's the story with the first one?
A pipeline for transporting oil is to be constructed from short steel pipes joined end to end.
Okay.
Each pipe has a circular cross-section as shown in the diagram.
Is it like this?
Yeah.
Yeah.
With internal and external diameters D and capital D of 1.10 meters and 1.20 respectively.
1.10 and 1.20?
Yeah.
Okay.
If the crane used to lift the pipes is limited to a maximum mass of 15 tons, show that the maximum allowed length of the pipe of each pipe is 10.6 meters.
Okay. And they give the density?
Yes, the density of steel 7,800 kilograms per meters cubed.
Okay, so I think what we could say is density is mass over volume. So that means 7,800 equals, and we're looking at the maximum situation, which is 15,000. Now, there's two ways to think about the volume. You can think of it as like one cylinder minus a smaller cylinder, or you can think of it as one cylinder and then you unroll it. I would feel like we should imagine it as one cylinder but being unrolled. Do you understand what I mean? Yeah. So, if we well, I'm just wondering how many people unrolled it and how many people did it as two cylinders. So who unrolled it? Did most of you unroll it? Or did you do two cylinders? Okay.
Could you show us how to do it then?
Which way do you want to see?
The other way, how all of you
Unroll it, okay, because the two cylinders is kind of easier to understand. So the way I imagine it is, well, it's obviously going to be longer than that, but it's almost like you cut it here and then you unroll it, so you have like a large rectangle line on the ground.
That's how they actually build pipes.
I don't. No, I think maybe so. Yes. Yeah. If you melt it like molten and then roll it up. Yeah, I think that's how they would do it. Yeah. So, how thick is this? Well, that should be 0.1 meters because of the difference between this radius and this radius. Now, how big is this? This is 2 pi r. And the top is supposed to be the same, but in real life it's not. It'll be a little bit smaller because the top part here is actually this piece, whereas the bottom part here is bigger because it's the outside piece. But it's only an approximation, and usually what you use is the bigger one anyways. That's what you use. Yeah. Let's see. So the volume here would be this by this by this. By the way, what's this length here? Oh, this is what you want, isn't it? L. Yeah. So if I go back to the question, the volume is 2 pi and the big radius is 0.6 because the big diameter is 1.2. Yeah? Times 0.1 times L. That's the volume. Are we okay with that, or we're not okay? Well, look, let's see what answer I get, and we'll see how it compares. So, if you can take out your calculator, we just need to type in 7800. No, what am I doing? Sorry. L equals 15000 over 2 pi 0.6, 0.1, 7800. And what do we get there? What do we get? Yeah, what's it say? You look very confused. What number is it? Yeah, go on.
10.645.
Is that what you got?
8.16.
Oh, maybe you mistyped it. What did you get? This is
6.458.
Okay, so 10.6 meters. Yeah? Now what does the question say it should be? I hope 10.6. Oh, good. Good. Yeah? Do you get the same answer when you did it as the 2? Yeah?
Same answer, but I'm not follow this one.
Yeah, that's okay. When you said 10.64, was that your answer or my answer?
My answer.
Ah, no, but what? I want to know if you type this in on the calculator, what do you get? What do you get? Oh, no, that can't be right, can it? You got 5.1 as well? Can you please type this in and tell me what it is? I need at least 2 people to confirm it.
So just a question of curiosity,
Yeah.
how would you account for the difference in the diameters?
You'd have to use a different formula for the volume. Some kind of trapezoid shape. I have to look it up what it is. You know a trapezoid?
Yeah.
Yeah, it'd be some shape like this, except 3-dimensional.
But then the thing is that when you fold it, it will leave a gap.
Yeah, well,
So then you have to account for that gap.
yeah. Cut it off or
Usually
something.
you actually weld it up after.
Yeah, because it's a bit malleable, so you can stretch it a bit. Yeah. What's this number?
5.3.
Oh, what? Okay, so look. Hey, look. If the answer is 5.3 something instead of 10.6, that means I missed a 2. A 2 has disappeared somewhere. So which 2 is missing? Where's the 2 missing? Is that D the diameter or the radius? Oh, it's the radius? Or is it the diameter?
Which D is? No, this big D is
Look at your teacher. Listen to his question. That 1.2, look at me, that 1.2 in the question, is that the diameter or is it the radius?
D.
It is the diameter.
Diameter.
Okay, so the radius is 0.6, yeah?
Yeah.
So where's my mistake then? Yeah, I see the mistake. I wonder, I'll give you, well, can anyone see what the mistake is? You think you can see it? No, that's not it, no. The mistake is, are you all watching? Right here. This should have been 0.05. Because from here to here and here to here, the difference is 0.1 for those 2 pieces. 0.05. Right, now that's better. Okay, I'm starting to think the other way with the 2 cylinders would have been safer. Right? Okay, let's have a look at number 2 now. Okay, read number 2 to me. Maybe you can read number 2.
The diagram
Yeah.
show how I don't know this pronunciation.
Try. I'm sure I'll understand. Aluminium. Yeah.
Aluminium spray
Yeah.
of extremo diameter D of 1 meter. And
1 meter. Okay.
And will thickness T, given that the total mass of the shape is 170 kilogram,
Uh-huh.
and that the density
Mhm.
of aluminum
Mhm.
is 2,700 kilogram. I don't know this how to say.
Try.
Maybe Q.
Mhm.
Calculate the thickness T of the wall.
Okay. Do I have all the information there, or did I miss anything? Diameter is 1 meter. Is that right? The mass is 170. Is that right?
Yes.
The density is 2,700,
Yes.
and the thickness is T.
Yes.
And what type of shape is it exactly? Is it like the last question?
Yes.
It's a sphere. Oh, it's a sphere. Okay. It's like this, and it has a thickness. Yeah. It's kind of like my paint example. Yeah. Okay. How about this time we imagine it as being 2 spheres? Yeah? A big sphere and a small sphere. Shall we do that? Okay, so again, let's use mass. Density is mass over volume. But this time the volume is the volume of the big sphere minus the volume of the small sphere. If we imagine a bigger sphere on the outside. Do you get what I'm picturing here? Like sitting on the outside like this. Okay, let's see what equation we can make. 2,700 equals 170 over 4 over 3 pi. Is that 1 meter for the whole thing, or just the inside? No, it must be just for the inside. It must be...
The question he asked, we should treat it like a flat sheet.
Okay, fine.
And if you want to, if you try to do this way, you cannot find a small r.
Okay, so we have to unroll it. Fine.
And you need to set x, and it will be very difficult equation. I have tried
So
to
is-
do it, but I give
You
up.
try. Okay, all right. So I won't try. You tried, and he says it's not going to work. So we'll have to unroll it then. Okay, so we have 2,700 equals 170 over. Now, we have to unroll this sphere. So again, it'll be like a big rectangle. The thickness will be T. I think we're happy with that. Yeah? And the area, what will that area be? It'll be this area, yeah, which is 4 pi or squared. Oh, I guess this isn't so bad. This will be 4 pi 0.5 squared t. Yeah? Okay, that's okay. So t is 170 over 2700 4 pi. Oh, well, hang on. This is nice. That cancels that, doesn't it? Yeah, so it's just 2700 pi. And that cancels that. Okay, so what does this become?
0.02004.
0.022.
0.02.
00, oh, like this. Okay, so that would be 2 centimeters. Yeah? Is that okay? Can you give me number 3, please?
But I want to.
Oh, question, yeah.
Yeah. So here's my first way doing the second question, but it's wrong. So I'm using the mass and the density to get volume.
Yeah.
I'm using volume to divide the area and get the. Is that okay?
I'll have to have a look at it in a little bit to see what you did.
Okay.
Are you sure it's impossible? Hey. Are you sure it's impossible if you make it 2 spheres?
Well, you only have the diameter of the largest sphere.
Yeah, but you know the diameter of...
It's difficult. It's a trouble because you need to set x for the small.
I don't think it's impossible.
You set an x for the half of the diameters. It's small diameters.
Who tried to do it using 2 spheres? You tried with 2 spheres, and did you get an answer? Who else tried? You didn't try this one with 2 spheres?
That's fine, and I get equal and an equation, but I don't get
I'm going to try. I want to see how difficult this is. So, 2700 equals 170 over 4 over 3 pi, and now the big radius. The big radius will be 0.5 plus t over 2. We won't make the same mistake as last time, because you have to half the t. Yeah? Minus 4 over 3 pi, or... Oh, sorry, that should be cubed. Cubed. Yeah? What do you think?
No, it's mistake.
Where?
Because the 0.5 is the half of the diameter of the big sphere, and you
So it
need
should
to
be
use
minus-
the small sphere
minus
inside.
0.2.
So you need to.
Is the 1 meter not for the inside, or is it for the outside?
External.
Oh, it's for the outside.
So
For sure?
Yeah.
It says it's the external diameter.
Oh, okay.
So
So that's that part then.
Yeah.
So the 0.5 is the outside one.
So you need the x for the small half of the diameter, and it will be difficult.
Only minus 0.2, yeah.
So it should be like this.
Yes.
Okay. This doesn't look too bad, does it? Because you can rearrange it and you can get 4 over 3 pi 0.5 cubed minus 4 over 3 pi 0.5 minus t over 2 cubed equals 170 over 2700. Yeah? So you can get 4 over 3 pi 0.5 cubed minus 170 over 2700 equals 4 over 3 pi 0.5 minus t over 2 cubed. Yeah? So then you can get then you can get 3 over 4 pi times 4 over 3 pi times 0.5 cubed minus 170 over 2700 cube root minus 0.5 equals minus t over 2. So that, and then times 2. Okay, so it's harder but not impossible.
It's impossible to get an answer, but it's easy to get the equation.
You are right. It's easy to get the equation, but more difficult to get the answer. And I hope that this works out to be 0.02 as well. But let's not check, just in case it's not. All right, let's have a look at number 3. Right. Can someone else can you give me number 3 if anyone has it open there?
A steel ball bearing is spherical in shape with a diameter of 4 millimeters.
Okay.
And there's 4 parts to it.
Okay. Part 1.
Part 1. Calculate the volume of one ball bearing in millimeter cube.
Okay, so that's 4 over 3 pi or cube, like this. 2, 4, 8, 16, 32, 64 over 3 pi, isn't it? What's this number, please, on the calculator? That'd be great. 510. Okay. Did you get that? You agree with that? Yeah? Yes? Yeah? Okay, what's part 2 then?
Convert it to
Meters cubed.
Oh, good. We know how to do that, don't we? So that's equal to 33.51, and this is like millimeters all cubed. And how big is a milli? It's 10 to the minus 3, isn't it? 0.001 cubed meters cubed. So what does that equal? That's 33.5 times 10 to the minus 9 meters cubed, or if I make this bigger, I make the other one smaller. No, sorry, I made that smaller, so I need to make this one bigger. Yeah? Did I do that right? Make this guy smaller, make that one bigger. Yeah, okay. Do you get that answer? Yeah? Okay, good. What's next now?
Estimate how many ball bearings could fit in a container which has a volume of 1 cubic meter.
So, if you have a box which is 1 meter cubed, how many? Yeah, it'll be 1 divided by 3.35 times 10 to the minus 8. So what's that? Roughly, what, 0.33 times 10 to the 8 or something, is it? 2.99. 7, like this?
That's what
Okay. Is that what we got? Roughly this. Yeah? Roughly 30 million, I think. Oh, anyways. What's the last part?
is your estimation likely to be an overestimate or
Ah.
underestimate?
So, do we think this answer in real life will be too big or too small?
Too big.
Because
Yeah. It'll be exactly, yeah. It'll be too big because this only works if you can perfectly put them in with no space, which of course you can't.
if it's a liquid, it will be more.
If it's liquid, if you melt your steel, you could. So this one, is it over or underestimate? Overestimate. Okay, that's okay, isn't it? Right. So yeah, number 2 was kind of hard. Number 3 was okay. And number 1 was okay. Yeah. Anyways, if you need to watch any of those again, it's recorded now. I saved it as a, what did I call it? Just tutorial.